Hi, I am Dr. Julia Nevarez. I am a professor in the sociology program here at Kean University, and I am also the principal investigator for the NSF Build and Broaden grant entitled Building Social Science, Data Analytics, and Visualization Skills in Cross-Disciplinary Research. This presentation seeks to add content and understanding of data analytics, especially focusing on visualization, data visualization. The title of the presentation is Data Visualization as an Analytical Tool, Deciphering Urban Data. I'm going to be talking about sensors, data processing, reinforcement learning, control and coordination of data. Large volumes of data generated through sensor-rich sentient environments have produced an unprecedented landscape for analysis, namely big data. Both public and private sectors increasingly mine these data streams to guide service delivery, shape policy, and develop strategic initiatives, often relying on algorithmic processing and, more recently, artificial intelligence. While vast data sets promise insight, their scale also complicates the identification of meaningful patterns. Data visualization has then emerged as a pivotal tool not only for communicating results, but also for supporting early-stage analytical inquiry. So these sensor-rich sentient environments through which we traverse on a daily basis, they use analytics and machine learning for the data that is accumulated through these sensors. These include big data, analytics, and machine learning for data prediction and congestion management, for instance. And here, AI algorithms analyze data and learn patterns, improving performance over time. Deep learning for spatio-temporal air pollution forecasting is another example. It's a subset of machine learning using artificial neural networks, enabling complex tasks. Natural language processing, NLP, utilizes AI techniques for dynamic traffic light optimization, for instance. And here, AI allows computers to understand, interpret, and generate human language. Agents learn to synchronize traffic lights across corridors, reducing bottlenecks and improving throughput. Computer vision is a multi-agent system that coordinate traffic and pollution reduction. And here AI enables computers to see and interpret images, data, video, and other visual data. What are all these sensors? I am always fascinated by the degree of detail that we can find in the environments in which we live on a daily basis. And I really like these very minutious detailed accounts of what constitutes the environments in which we live. We have roads and we have buildings and we have other environmental components in urban landscapes. And another layer has been developed with sensors in what in the literature is generally referred as IoT, the Internet of Things. There are real-time traffic sensors, air quality monitors, data fusion, cloud computing, edge processing for the data that is produced by these sensors. They They focus on mobility, traffic management, traffic optimization, congestion control, air quality monitoring, pollution detection, emission analysis. And there are also wearable technologies, and there is a very large number of wearable technologies examples. And that includes smart watches, fitness trackers, glasses for gaming, movies, and cameras for taking pictures with the glasses, smart clothing, continuous glucose monitors, sensors for like smart patches to monitor blood pressure and sugar spikes, power gloves, smart helmets and vests. There are so many different kinds of smart shoes and implantable sensors, specialized health wearables that I just want to convey to you the large number of sensors that we are already living with. The ones that are used in urban environments usually focus on traffic flow mobility, mobility services, public transportation optimization, vehicle communication, and also more environmental in terms of air quality, pollution monitoring, integrated systems. So they usually in urban environments focus on two aspects. One is mobility, traffic, and the other one is air quality monitoring, as I just mentioned to you. Now, there is a smart city urban development and sustainable development. There are smart cities from scratch, and there are other cities that in the way that they develop, they adopt some of the characteristics of the smart city urban development. And smart city has many different definitions, but basically it's really anchored on this data-driven, sensor-led way of gathering large amount of data through the sensors that I just presented to you previously. And that poses data challenges, right? When we are living in an urban environment where so much data is collected, and this smart city, sustainable urban development combined, it's the one that produces all these sentient environments that are constantly collecting data from our bodies and our experiences in space. So it's really producing adaptive urban environments that change according to what is necessary in terms of traffic, in terms of pollution, in terms of mobility, in a cycle of sensing, learning, and acting, right? It's a loop. It's a feedback loop that informs in terms of some three important issues: interoperability, scalability, and cost efficiency, that each poses certain challenges. Interoperability refers to the ability of aligning personal mobility with citywide sustainability and livability goals through sensor networks, AI models, and decision engines. As sensors are produced by different manufacturers, they tend to compromise the seamless data exchange. That is one issue. Scalability is another. Time series forecasting and predictability. That's what scalability refers to. And in the case, for instance, of air quality sensors, they help the government issue health advisories and adapt traffic regulations in anticipation of hazardous air conditions. I remember once in New York City that was the case with all the smoke that came from the fires in Canada. They pilot projects in well-funded urban centers, usually, and then it is hard to apply those same pilot projects to contexts where resources are more limited. So there is a class and wealth limitation in that regard. Cost efficiency is, it refers to the cost of reference grade monitors, high bandwidth connectivity, and the skilled technical staff that could limit the widespread adoption of advanced sensing networks. And so when we are talking about big data visualization as a step into analytics, what we are trying to convey here, based on the literature that I examined, is that when we recreate large volumes of data into a representation, a visual representation that can offer sometimes leads into what are the tendencies and the patterns that we see represented in the data, that through other channels might be a little bit more cumbersome to detect strictly on the analysis of the data itself. So the argument that I'm making in this presentation is that data visualization can provide, especially for large data sets, a way, a tentative first step into the analysis of the patterns that are represented by the data in the visualization. Usually, we analyze the data and then we present the visualization. And I think that the point that I'm trying to convey here, based on the literature that I'm also been examining, is that representing the data after it has been configured, clean, and ready for plotting, right? Visually representing the data can actually facilitate the process of analysis. There are different urban data types, as I mentioned to you. There is urban mobility data, social network data, and environmental data. And visual learning is automated machine learning or data mining, where the algorithm is able to interactively query users through visualizations to optimize and obtain desired outputs that then can be represented, and we can focus on the clusters and dispersions in the concentration and dispersion of the plotting of the data to kind of lead us in terms of what are the aspects that need further consideration from the data. So here, I just created a graph using ChatGPT with synthetic data, mimicking patterns that tend to occur in real life. And I just asked ChatGPT to provide a 3D synthetic data analysis of Hudson Yards pedestrian mobility. And we can see where the points in the graph are concentrated, and that highlights that it is during the weekend in the afternoon where that space is most used. This is something that when we are using large scale data can help us, as I mentioned before, formulate, anticipate tentative next steps for data analytics. In other words, data analytics visualization can be a way to improve understanding and decision making for stakeholders like local governments, businesses, citizens, visitors. And the visualization can support decision making. It can maximize our understanding of large data sets in ways that are more immediate. And it is based on information that is directly perceived, used, and interpreted, excuse me, in terms of resource identification, selection, data extraction, data analysis. And when we are considering smart city urban development, for instance, there can be smart city platforms, dashboards, as decision support systems like game platforms and virtual simulation environments. And these are all possible ways in which the data can be visually represented to facilitate decision making, to facilitate conversations about understanding how urban spaces are used. These visual representations here, I would like to use the metaphor by Stigler. He calls visual representations and graphs external portensions, and by that he means that they are external to the way that we tend to experience and perceive environments, and it somehow involves a visual reasoning of sorts to be able to then use a graph as an external tool for analytical purposes, suggesting directions for potential exploration to reveal patterns, clustering and querying data trajectories for further analysis. I certainly hope that this presentation piques your interest in data analytics and data visualization. Here is a bibliography with a few references that you might find useful to go deeper into understanding data analytics and especially data visualization. I'm also available to have conversations, and you can contact me via my email. I'm fascinated by the way that urban development is happening right now, data-driven urban development, in which sentient environments are collecting a huge amount of data from our bodies to inform decision making and many other aspects of our lives in urban environments. Thanks for your attention.